So the next thing to get into is the Scala case class. And as I mentioned here in the book, the case class is like a regular Scala class, but it has additional features built into it automatically. And these features are intended primarily for programming in a functional programming style, but they can be used in object-oriented programming as well. If you're familiar with some other programming languages, a case class is similar to a data class in Kotlin. It's a little bit less similar to a record in Java. I think it was Java 14 and newer has the concept of a record, but I don't think it has these other built-in methods. So a record is similar to a structure in C and probably Rust. So in this next section here, I show the features of a case class. So again, it's a regular class, but it has additional code that's built into it automatically for you. So the first method it has is called an apply method, and that's added in the companion object. And this serves as a factory method for us to create new instances of a class. And I'll show what this means as we go along. The second feature is that each constructor parameter is considered a public val field by default. So this means that you don't have to use the val keyword. You just type in the name of the parameter and its type. And then accessor methods are generated automatically for each constructor parameter, but there are no mutator methods. Again, this is intended for functional programming, so there wouldn't be any mutation involved. A third thing here is that, and this is a cool thing, an unapply method is generated, which makes it easy to use case classes in match expressions. So this is really cool. It's huge for functional programming, and I'll demonstrate this as we go along. A copy method is generated, and what this does, it lets you easily clone an object, and so you clone an object to create a new object, and then you change some of the fields during the cloning process when you create that new object. The next feature is that equals and hashCode methods are generated automatically for you, and this lets you compare objects using equal, and then it also lets you use them as keys in maps and sets, which is very important. And then finally, a default toString method is generated, and that's primarily useful for debugging. And then as I note down here, the way you create a case class is all you do is you add the case keyword before a class. So let's go ahead and switch over to the REPL now. So whereas before I would create a class person, and then I might say var first name. Yeah, that's correct, sorry. Var first name string. It seems so weird. I do this very rarely. Last name string. So that would be a regular class, and in a case class what you do is you get rid of that, and if that was a val you would get rid of it as well, and get rid of all that, and you just put the case word right there, and that defines a case class named person. So now I could create a person by doing this. So I say val p equals person, and I might call this Reginald, and Dwight being the last name. So that creates a person, and I can access that first name. You see, like that, I can access the first name. I can also access the last name. But what I cannot do is say person's first name equals Joe. You see, I get a reassignment to val error right there. And again, that's because case classes are intended to be used in functional programming, and these two fields are val fields by default. And so the way you get around this problem is you say, when that person changes their name, I would say val p1 equals person, and this is where the copy method comes in. So you say, I want to copy, and I want to change that first name. So during the copy process, or during this cloning process, I want to change that first name to Elton, and I want to change the last name to John. And so now you can see that the person, P1, is created from the original person, P, using this copy method. And during this copy or cloning process, I changed the first name to Elton and the last name to John. So that gives me this new person right here, which is based on this original person here. And the next thing I want to show is how case classes work with match expressions. So I'm going to just copy and paste some code that I have over here. So I'm going to start with a trait that's called animal. And then I am going to create some dog and cat classes. So first one I'll create is this dog class that extends animal. And then similarly, I can create a cat class like that. and both of those extend animal. And now I can create a speak method. So let's create a speak method, and this will get these two types of animals to speak. So I take an animal as an input parameter, and then I am going to return a string from this function. So then I say a match, or on that animal, I want to run this match expression. So for the case where it's a dog who has a name, then what I want to do is I want to return this string that says dog with this name, says woof. But if it's a cat, if it's a case cat name, then I want to say that the cat $name says meow. And then you see I get this enormous error message. So then if I scroll back here to this first error message, you start to see what's wrong here. It says dog cannot be used as an extractor in a pattern because it lacks an unapply or unapply seek method. So I'm not going to worry about the unapply seek, but it just lacks this unapply method. And that's why it cannot be used as a case here in a match expression. And then the errors compound because then it says, well, I can't find this name here. And again, that's failing because of this initial error here. So what happens is when you're writing this code, it's actually using this technology. It's called an extractor. So I'm trying to extract name out of dog, but with a basic dog class. Again, this is not a case class. This is a plain class. With a plain class like this, I get this error message and it fails. So to fix this problem, what I do is I just convert the dog class to a case class. Oops, I need to get rid of that val as well. We don't need that. And that creates a case class named dog. And similarly, I will come back over here and do the same thing for a cat. And that works. And now when I go back to my method, and then you see that it compiles as desired. So now this case and the second case both work because an unapplied method is being generated for me automatically with a case class. And so now I can create a dog, and we'll call that one Rover. And I can create a cat, call the cat Morris. And now I can say speak dog and speak cat. So even though you don't know exactly what an unapply method is or how exactly an unapply method works, which I will show later, either in this course or the next course, the important thing is that by making this a case class, you can use it in a match expression, as I showed right there. Now that last example with the match expression worked because a case class has an unapply method. And now I want to show what happens when a case class does not have an equals method and a hashCode method. So to do this, I'll create a class named human. And this is just a plain class, so I'll give it a name. So this is a plain class named human, and it has one constructor parameter, which I'm calling name, and I'm making it a val field, and it's a string. And there's nothing wrong with that. Oh, and I want to give it a toString method so we can see the output properly. So I override def toString, and that's just going to be the name. So you see that there, and now I can create, or let's see what happens actually. Now I'm going to try to create a set, and I'm going to have that set contain several Alvin instances. So you don't have to see me type, I will copy that. And now, as you may know, a set is supposed to only contain unique instances. So I'm giving it 3 instances of a human named Alvin. And if everything were proper, a set would say, well, I'm only going to contain 1. I'll just have 1 instance here. Oops, sorry, I can't type. Let me put another comma there. And there we go. And that's the problem. So I created a set of humans. And as you can see, it contains 3 elements. They're exactly the same. And a set should not work like that. It should only have 1 instance. So to fix this, I can actually get rid of that toString method because the case class will have its own toString method. I get rid of that val field, and I just make that a case class, human. And now when I go back to that set code right there, I again try to put 3 instances of human in there. this time using a case class, and now you can see I get the proper result, which is a set that contains only one human named Alvin. And that happens because the case class has an equals method generated for you automatically, and has another method called hashCode. And both of those are used under the covers, and they're actually used in equal comparisons, and they're used for the keys in a set and for the keys in a map. And then the one thing I didn't show was the equals comparison. I mentioned it, but I didn't show it, so let's go ahead and do that real quick. So I'll create a regular class named human and give it a name string like that. So then I will create a1 equals a human, and call that one Alvin. And note I don't have a toString method, so instead of seeing the name there, you get that output here, but I don't need a toString method for what I'm showing. And then val a2 equals that, so then I could say a1 equals, equal a2. So you think that would be true because human just has this one input parameter named name, and they're both Alvin, so when I hit enter, you would expect that to be true, but it actually turns out to be false. And that's because they don't have the equals and hashCode methods being generated for you behind the scenes. And so if I go back up here and I change that plain old class to a case class, and then I recreate those instances, A1 and A2, now you'll see that they should be equal. And there they are. So before they were false, now that's true. And as I mentioned with the set example, that works because behind the scenes, human now has an equals method, and it also has a hashCode method. One thing I'd like to do here is a little bit of a bonus, is to show you a little bit more about how this works, or what I'm talking about when I say that there aren't equals and hashCode methods generated for you automatically. So to do that, I can cat that out. I've created this person class, so I'll cat that out, and you can see that this is a class. It's a plain class named person, and it has this one parameter named name, and I made that a val field. So I've switched back to Scala 2.12 to demonstrate this. So I will say Scala C person. So that will compile this class, and then I will do that, and you can see that now I have a .class file. And the way you can look at this is kind of fun. You use a java p command, and then you can say person. So this is kind of interesting. It disassembles this class file here into something that's essentially a Java class, and it shows that it's compiled from person.scala, but this is actually Java code right here. And so what this is showing you is I disassembled this. I used this command to disassemble this class, and it created this source code. So as far as the Java compiler or Java P is concerned, all I have is a method named name, which returns a string, and then I have this constructor named person, which takes a string parameter. So I'm kind of assuming a little bit that you know Java, or that you've seen some simple Java code like this. So that's a plain class. So now if I go in here and I say edit person.scala, and again I make that a case class, and I get rid of that val field. So now that's a case class. And then I go back to Scala C and I compile that again. Now you see that I'll have more output over here. So not only do I have a person class, which I had before, now I have this person $sign class output right here. And I know, because I worked with this for a long time, I know that this represents an object. So this one represents a class. This one actually represents an object, or what we call a companion object to this class. So now when I do a Java P on person, you're going to see much more output here. And again, this output looks like Java right here, and everything through here looks like Java. And the important parts are that I mentioned we have an unapply method, which is what makes a case class work so well in a match expression. We have the copy method, which I demonstrated earlier. And then most importantly, for what I was talking about with using a case class with equal, and using it with a set and a map, using it as keys for a set or a map, is that we have this hashCode method that's generated for us automatically, and we have this equals method that is generated for us automatically. And again, we get all of this output here as compared to those previous lines. This is what I got with a plain class, and this is what I get with a case class.